Thank you, Nolan, to introduce our data set. And here I'm gonna check the assumptions for our linear regression model for object one. And when you want to see the left side and on the top of the scatter plot of residual, you will see the randomly scattered plot of the residuals. And it says our data set met the equally standard deviation assumption of our linear regression model. Also, when you want to see the QQ plot on the left side, you see the slightly S-shaped QQ plot, but we can lean on the central limit theorem because our data set is enough samples. So our data set meets a normality assumption for our regression model, linear regression model. And when you want to see the Cook-stick plot with leverage, it displays low leverage and low Cook-stick. And I can say we have highly chance to our model will not gonna be highly sensitive, the outliers due to the outliers. So I want to introduce about summary of our regression models, and we have a few data sets and highly statistically significant of our model parameters for the intercept and slopes for percentage expenditure and income and adult mortality and some health factors. And the R-square value is 0.8871, says 88% of variation explained by this model. And what I want to do next is extra sum of square test, because we would like to test if there is evidence from an extra sum of square test to suggest that the inclusion of economic and social factors. So the answer is there's not enough evidence to suggest that adding economic and social factors will be useful in the model. And when you see the p-value of this calculation is 0.41 with 0.05 significant level of test. So I want to introduce a little bit detail of our reduced model used here. So we only select health-related variables like hepatitis B, BMI, and polio, HIV/AIDS. And this reduced model has highly statistical significant variables for our models and also coefficient for our models. And the multiple R-square is 0.7848. The last research question is to determine if health-specific measurements such as immunization rates and BMI are associated with life expectancy after taking into account economic factors. Of course, we can include here about the social factors. If they are, what percentage of variation to the medical specific variables in the model explain? And what I did is to determine R-square difference between full model and the reduced model. And the answer is the medical specific variables in the model explains 90% of variation for life expectancy. And yeah, this is my part. And I'm gonna toss to the Trevor for next analysis. Thank you.